Okay, this is our video lesson on how to graph parabolas. At the beginning of class, I kind of showed you guys lots of real-life examples of parabolas. So, for example, you have the St. Louis Arch. Okay, St. Louis Arch comes to a maximum. This is what we call the vertex, and it comes to a maximum because it's the highest point on the graph. Here is the George Washington Bridge. Here's the parabola, this curvy shape, and its vertex is a minimum. Okay, so here's a fountain. Its vertex, we have lots of parabolas here, and their vertices, which is plural for vertex, they're at maximum. Here is a satellite dish. Inside the satellite dish, you find a parabola with a minimum vertex, and the McDonald's arches, and a little balloon array. Okay, so believe it or not, if I were to graph the equation y equals x squared, and I'll show you what I mean by that in a minute, you're going to see we get a nice shape, and we're going to get a parabola. So what do? Well, first of all, I gave you some x values, and we can plug those x values into this equation, and every x value that we plug in will produce a y value. So for example, if I plug in, I want to plug in the number 3 to start off with. Okay? Y is equal to x squared. That's the relationship between x and y. So when I want to find y, I'm going to do parentheses 3 squared. And 3 squared is equal to 9. So I can plot the point 3, 9 on the graph. So to remind us what this looks like, a point goes x, y. So I start at the origin, and I go 3 units in the x direction, which is the horizontal direction. So I go positive 1, positive 2, positive 3. And the other axis is called the y-axis. So I go up positive 9 units. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And I plot a point right here. That's the point 3, 9. All right, I want to continue to do this. So instead of 3 being the x value, 2 is the x value. So 2, if I square it, I get 4. So the point 2, 4 is now on my graph. So I go 2, 1, 2, 3, 4. Now I'm going to do a negative point with you. I want to do negative 2 with you. It really important is to surround, when you plug in a letter for a number for a letter rather, you take that number and you put it in parentheses. And that replaces the x, and the square goes outside the parentheses. So negative 2 squared, I'll do it to the side here, is really negative 2 times negative 2, which is positive 4. So this is positive 4. So the point on the graph is negative 2, comma, positive 4. And so I'll go negative 2 is 2 to the left and 4 up. And your job now is to pause the video and fill out the rest of the y values. So I need you to pause the video, fill out the rest of the y values. Okay, so the y values you should have gotten after you paused are 9, 1, 0, and 1. And now you can plot the corresponding points. So negative 3, 9, negative 1, 1, 0, 0, 1, 1. So if you plot those points, you'll get negative 3, 9 up here. So you should probably pause and do this. Negative 1, 1, 0, 0, 1, 1. And if you notice, if you were to connect the points with a nice smooth curve, they would make that shape, which is called a parabola. So I'm going to do that. Connecting these points with a nice smooth curve. And now I could have asked you, theoretically, to go to 4 and 5 and 6, etc. So what I'm going to do is I'm going to put arrows at the end of this graph to represent that. You could have gone on and I could have asked you to continue on with the table. And this is the graph y equals x squared. So I label the graph. Now, we're not always going to plug in numbers because it gets to be a pain in the neck. So we're actually going to use our calculator. So make sure you have your calculator out. Pause if you don't. And we're going to put we're going to actually go to the home screen. So here's your home screen. And we're going to press y equals because we're typing in a y equals equation. Whoops. Sorry. Okay. And we're typing in y. Let me just move this. Okay. Not what I wanted to do. Thank you for being so effective here. Here we go. Okay. And we're going to type in y equals x squared. And if you see above the graph key, it says the word table. If I press second graph, I will get a table. Now, the table's not the one that we have. If you see, it starts at 0, and our table starts at the top at -3. But I can scroll and get this table on the calculator. Whoops. There we go. I can actually scroll and get the same table of values on the calculator. So there is the table of values from the calculator. Okay, it's the same exact table of values that we just did by hand. Now, there are some parts to this that we need to define. Okay. So actually, let me split screen this. Not quite going to work the way I wanted it to. Let me just unlock this, and I will stretch this. Or not. Let's see here. Okay. Anyway, we have to fill in some definitions here. A quadratic polynomial, okay, it's a polynomial with x squared somewhere in it. Quadratic means something squared, okay? A parabola is the shape of the graph. Shape of a quadratic graph. So it looks like a U, or it can look like an upside down U. The vertex, or the turning point, is the place where the graph turns around. So here the vertex is the point 0, 0. This is the vertex because that's where this graph goes from coming down to going up. That's where it turns around. The axis of symmetry is the mirror line of the graph, of the parabola. And what I mean by that is if you look at this line right here, whoops, hey, this line right here, it splits the parabola into two equal kind of parts that are mirror images of each other. Okay? And then many times you're asked for the equation of this line. So the equation of this line is interesting. Okay? The equation of this line is, let's think for a moment. If I took this line, I want to go back to the regular screen. If I took this line and looked at a bunch of points on it. So for example, if I took this point is 0, 6. This point is 0, 8. This point is 0, 2. This point is 0, -1. What do all those points have in common? And the answer is their x value is equal to 0. So in this example, so just in this example, the axis of symmetry's equation is x equals 0. It always starts out with x. So there's always going to be an x, and then you have to figure out the number. Now, a couple of things. I'm not always going to tell you what x values to plug into the calculator or to have in the calculator. So notice something here for a minute. If I look at my table, there's a very strong pattern. At the top and the bottom, I have the same number. I have 9s. Okay? Then I have my 4s. So watch. Let me circle this instead of arrows. I have my 9s. Then I have my 4s. I have the same number. Then I have the same number again. And then I have the vertex. So when we graph a parabola, we're looking for this pattern in our calculators. So let's do the next one. So we have y equals x squared minus 4x plus 2. So I will go to the calculator and clear out whatever's in there by pressing clear and type in x squared minus 4x plus 2. Now, I want to generate a table. Notice I didn't give you any x values. Though your paper is blank, so is my smartboard. So if I go to second graph, I will get a table. Now notice right now, this table, this y value that I have highlighted is 23. The one at the bottom is negative 1. I want those y values to be the same. I want to see a pattern. So I can go up the list. But now if I go up the list, notice my y values are getting bigger. And they're going to continue to get bigger. This is no good. So I'm going to go the other way. Okay. I want to go the other way. Now my y values are getting smaller. Okay. And now if you notice, I'm starting to see some values that are the same. So for example, at 0 I have 2. At 4 I have 2. I'm going to go one more. And lo and behold, I get a very nice pattern here. I get 7s at the top. So let me show you what I mean. I get my 7s. I get 2s. I get negative 1s. And I get a negative 2 in the middle. So I'm going to copy this table down from my calculator. This is the work. Okay? So I'm going to copy down this work into my table. This is the work for graphing a parabola. Getting the table on the calculator is the work. And I'm just going to copy down the numbers just as they come. There are my numbers. Okay? And I can plot these on the graph. So negative 1 comma 7, there it is. 0 comma 2, there it is. 1 comma negative 1, there it is. 2 comma negative 2, there it is. 3 comma negative 1, there it is. 4 comma 2, there it is. And 5 comma 7. And something to notice is that your y value should kind of line up. Like if you're at negative 7 over on the left, you're going to be at negative 7, positive 7 on the left. You're going to be at positive 7 on the right, etc. Now here's my parabola, so I'm going to connect and graph it with a nice smooth curve. Arrows at the end. I label the graph. I'm going to label it y equals x squared minus 4x plus 2. And then I'm going to answer questions. The vertex. The vertex is the turning point. So from the graph, I can see it as 2, negative 2. In the table, it shows up in the middle. Okay? The vertex is the middle pair, and that's your vertex. The whole thing, 2 comma negative 2. It is on the bottom of the graph, so therefore it is a minimum. And the axis of symmetry equation is interesting. The axis of symmetry is right here. It's the graph that cuts through it's the line that cuts through the vertex. Okay? And it cuts at x equals 2. Another way to remember this, the axis of symmetry has an x equals in its equation. Yes, you must put x equals. Otherwise, it's not an equation. All right, I'm going to do one more with you that's not in order here, I think. we're going to do negative x squared. So jump to number 4. We're going to do negative x squared plus 8x minus 12 together. So y equals, clear out whatever's in there, and I'm going to put a negative x squared plus 8x minus 12 into my y equals. And then I'm going to go to my table. And notice, right now I don't have a pattern. So I want to try to find one. If I go up the list, my y values tend to get more negative. I'm getting very big negative numbers, so that's not a good direction to go. So I'm going to go down the list and see if I can get some pattern here. And now I see 2 3s. That's good. And now I see a 0. That's good. And now I see a negative 5. And lo and behold, there's my pattern. So here's my pattern. And I can copy this table directly into my calculator. I have 1, negative 5, 2, 0, 3, 3, 4, 4, 5, 3, 6, 0, and 7, negative 5. Now, I didn't give you an axis on your graph. Notice in the other problems, I gave you the axes. So here's an x-axis, here's a y-axis. And my question is, where should we put them? Now, if you notice, I need room from 1 to 7. So I need lots of positive room. Lots of positive room. So if I put my axis in the middle, I have equal negative and positive room. If I put my axis to the right, I have lots of negative room. I want to put my axis to the left so I get lots of positive room. And now my y's are both negatives and positives. So I want to put my we just put the y-axis where it was. I want to put the x-axis in the middle. So I have lots of negative and positive room in the y direction. And so now I have 1, negative 5. 2, 0. So I should really be labeling everything. Negative 4, negative 3, negative 2, negative 1, 1, 2, 3, 4, 5. 3, 3. 4, 4. 5, 3. 6, 0. And 7, negative 5. And there is my parabola. Or if you graph it. And this is the parabola y equals, missed the vertex, negative x squared plus 8x minus 12. So the vertex is, again, this top point now, the turning point, or it's in the middle of our table at 4, 4. In this case, it's at the top of the parabola, so it's now a maximum. And the equation of the axis of symmetry is just x equals the vertex value, which I mishighlighted. Hold on a second. There it is. It's just the x equals of the vertex. Or you can draw it in. And another way to see it, if you draw the vertex, the axis of symmetry rather in, it cuts the x-axis. This is the x-axis. It cuts the x-axis at 4. So its equation is x equals 4. And from here, you should be able to do any of the problems I give you.